What if the cosmos is sending us visitors, and we don't even realize it? Recently, a new massive comet was spotted, and this completely changes everything. We've spotted a comet unlike anything we've ever seen. We already knew about 3I Atlas. It was already massive on its own. But now, Swan is here, and it's not just bigger, it's also blasting out over 1,000 times more energy. Usually, new comets show up as faint little specks you can barely spot with huge telescopes. But this one? You can even spot it with binoculars. By the next day, it was official. The International Astronomical Union named it Swan. But here's the thing. This didn't look or act like any ordinary comet. And that's what had everyone on edge. What if the cosmos is sending us visitors and we don't even realize it? Imagine one of these objects sliding past Earth, studying us, and then vanishing into the darkness, never to return. It sounds like science fiction, but is it? Is 3I Atlas just a rock from interstellar space? Or was it a scout? And if it was, what does it mean now that a new giant, Swan R2, is approaching? An object that returns once every 22,000 years. Before Swan ever appeared, the focus was on 3I Atlas. Astronomers recognized it as only the third interstellar object we've ever detected, after Oumuamua in 2017 and Borisov in 2019. At first, it seemed like just another comet passing through, but the longer it was tracked, the stranger it looked. Its brightness flickered in a way no normal comet does, pulsing as if hidden surfaces were being revealed. The tail was inconsistent, fading in and out when it should have been steady. And then there were the unexplained nudges, tiny accelerations that didn't come from gravity at all. Even its spin looked wrong, more like something under control than a random chunk of rock. Atlas wasn't drifting in casually. Its path was steep, precise, and deliberate. That's why some people started calling it a possible scout, a visitor unlike anything we'd expect to see on its own. And just as Atlas was approaching from one side, Swan suddenly appeared from the opposite side. Two objects, from two entirely different origins, arriving at the Sun almost at the exact same time. The odds of that happening by chance? They're practically zero. Then came the most startling discovery. Spectral analysis revealed nickel without iron. In nature, nickel and iron form together. To separate them requires energy, heat, and processing, industrial processes. On Earth, this is not accidental. To find nickel without iron floating through interstellar space, that is a cosmic fingerprint of technology. And it doesn't stop there. Observational data suggest 3I Atlas carries an energy signature of roughly 10 gigawatts, enough to power a small city. Swan R2, the incoming giant, is even more extreme, an estimated 10,000 gigawatts. These aren't rocks drifting through space. These are energetic, possibly active objects. Physicist John Brandenburg has warned that interstellar visitors like this may be exactly what they appear to be, probes sent to quietly observe civilizations. We must consider the possibility that we are being observed, he says, quietly, patiently, without interference. And this is not just history. In a few days, 3I Atlas will enter the field of view of NASA's Mars Reconnaissance Orbiter. One of the most powerful cameras ever sent beyond Earth will see its core directly. Will it reveal a small, reflective fragment? Or something much larger, engineered, deliberate? Avi Loeb believes this is our chance to finally measure the true size of Atlas's nucleus. And then there's Swan R2, bigger, stranger, moving with a precision that makes Atlas look almost clumsy. Its path doesn't meander like a comet's should. It traces a line as if plotted long ago, calculated to the smallest degree. This is where history and the heavens collide. Swan R2 is on a return cycle of about 22,000 years. That means the last time it swept through our inner solar system was at the very end of the last ice age, right when the first great human settlements were rising, and our ancestors were carving stories into stone. Could the myths of gods descending from the sky, blazing omens, or fiery visitors be memories of Swan's last visit? Could the legends of catastrophic events, celestial warnings, and star-born deities be the faint echo of something our species once witnessed but could not explain? Now, two extraordinary visitors arrive almost together. One, Atlas, carrying anomalous energy. The other, Swan R2, returning after 22 millennia. The timing is beyond uncanny. It feels less like chance and more like a pattern reasserting itself. And then the universe provides the perfect stage. In mid-October, both Atlas and Swan R2 slip directly behind the Sun from Earth's perspective. For nearly 2 weeks, they vanish into the glare. Our telescopes on the ground are useless. Even our satellites, normally able to track the faintest light, can't cut through the brightness. This blackout doesn't come at a random moment. It happens at the exact point when the two objects reach their closest approach, not only to the Sun, but also to one another. It's the moment when their true nature might be revealed. And yet, it's the one moment we're forced to look away. During that window, if Atlas fires another burst of unexplained acceleration, or if Swan shifts its trajectory, or if either one does something that breaks every natural law we know, we won't see it. The Sun itself becomes a blinding curtain, shielding them at the most critical time. And that's what makes it unsettling. Because this isn't just inconvenient astronomy, it feels like a setup, a stage designed to keep the audience in the dark until the act is finished. So ask yourself, is this just cosmic coincidence, or timing too perfect to ignore? Throughout human history, the sky has never been just empty space. Ancient records are filled with stories of fiery visitors, blazing stars, and omens that terrified entire civilizations. The Babylonians carved warnings into clay tablets. The Mayans tracked mysterious lights across their calendars. Medieval scribes wrote of blazing stars that appeared without warning, linked to plagues, wars, or the fall of empires. But what if these weren't just myths or exaggerations? What if some of them were real encounters with long-period objects, like Swan R2? Massive bodies returning on a cycle so long that each pass only brushes against human history, once in tens of thousands of years. Imagine standing in an ancient city, staring at the horizon as a brilliant object cuts across the night sky, stretching wider than the moon itself. The people wouldn't have had the science to explain it. To them, it would have been a god, an omen, a warning carved into collective memory. And now, more than 22,000 years after its last return, Swan is here again. The past and present fold into one another. What ancient civilizations feared and worshipped, we are now seeing with telescopes and data streams. And the haunting question remains, were they seeing what we are seeing now? And did they know more than we give them credit for? Governments and agencies that usually leap at the chance to control the narrative stay quiet. The European Space Agency avoids direct commentary. Even as the Mars orbiter prepares to send back images, even as Swan grows brighter, even as energy readings climb beyond anything natural, official voices stay muted. Why? Are they truly caught off guard? That seems unlikely, given the global web of telescopes and satellites. Is it secrecy? That would fit the pattern, classify the data, bury the findings, and let the public believe these are just comets. Or maybe it's something more careful, more calculated, a decision to withhold information because the implications are too disruptive. Because once you admit that Atlas accelerates in ways that look like controlled maneuvers, or that Swan is radiating power at levels that rival entire civilizations, you can't take that admission back. Maybe someone already knows. Maybe behind closed doors, the truth of what Atlas and Swan are has already been whispered. And the silence isn't ignorance at all. It's strategy. Now, imagine the orbiter finally gets a clear shot of Atlas, and instead of the usual blurry comet images, the data shows something different. Patterns where there shouldn't be patterns. Shapes that don't look random. Readings that don't add up to ice and rock. Energy levels confirm the scale of the mystery. Around 10 gigawatts for Atlas and 10,000 gigawatts for Swan R2, far beyond what we expect from natural objects. If Atlas isn't what we thought, it means our solar system isn't just getting visitors, it's getting something else. And as that realization spreads, Swan R2 emerges from behind the Sun, larger, closer, and on a return path that spans 22,000 years. At that point, the question shifts. It's no longer, what are these objects? But why are they here? And what happens if they're not just passing through? So what is 3I Atlas? A drifting rock? A relic from deep space? Or something sent ahead of time, a scout marking the path before something larger arrived? And what about Swan R2? On paper, it's just another comet, but its orbit tells a different story. A return cycle of more than 22,000 years, stretching back to the end of the Ice Age, when humanity was just beginning to rise. Could the fiery omens and sky gods of ancient myth have been echoes of Swan's last visit? Now, the cycle repeats. Atlas is the first to swing by the Sun, October 17, 2025, at around 203 million kilometers. Then, only 3 days later, Swan follows. But Swan doesn't just follow. It plunges deeper, at 150 million kilometers, almost the same distance Earth itself orbits the Sun. It arrives closer, brighter, and radiating over 1,000 times the energy. Two massive objects from opposite directions converging at nearly the same time. To call that chance is almost impossible, which leaves the question hanging in the air. Coincidence or connection? The universe rarely offers answers. If you want to continue following the cosmic mysteries the world won't talk about, feel free to subscribe. Until next time, keep looking up and keep wondering.